Continuing on the bottom of page 1 here of 6.7, take a moment now to look at what you just saw regarding negative exponents. Copy down, write down any questions you might have. You might even go try some of the problems at the beginning of the problem set before you jump into this next try. And this try one, again, is going to have you ask the question, what's different? What's different between the one we're seeing here, number 18, 4 to the negative 3 over 2 to the negative 2. What's different about this one than the first two we saw just above in your notes? I'll give you a minute to think about that and try to come up with the answer for this one. What's different about this problem is that there's negative exponents in both the top and the bottom. Or to be technical, the numerator and the denominator. Okay. Does that change the rule that we're going to apply? No, it doesn't. It just means we're going to apply it twice. We're going to apply the rule to the top part. We're going to apply the rule to the bottom part. We aren't going to go crazy on anything. The negative exponent is going to do its job of moving it to the opposite end. So 4 to the negative 3, this one is going to become 4 cubed on the bottom. And the 2 to the negative 2 is going to become 2 squared. Notice the negative has done its job and disappeared. It's going to become 2 squared on the top. The exponent remains the same, 2 and 3, but the negative has done its job by moving it to the opposite location of the fraction. So what that would look like is 2 squared over 4 cubed is equal to 2 squared is 4, 4 cubed is 64, and we could reduce that as 1 over 16. So 4 to the negative third over 2 to the negative 2 is really 1 over 16. Now what if you have something like this, number 22, where you have 3/4, the whole thing in parentheses, raised to the negative third? Or what if you have something like number 54, x to the 6th over x squared, the whole thing raised to the negative 3? The instructions are simplify each exponential expression, assume that variables represent non-zero real numbers. Now the book indicates that this is a whole new situation, but really it's not anything that we haven't done already. We've just got something raised to the negative exponent. What does a negative exponent do? A negative exponent flips the base, or it moves it to the opposite spots. So if this were to flip, if this were to move to the opposite spots, the negative would do its job, and this would become 4/3 raised to the third power. Notice the 3 is the same. The negative no longer is there because it's done its job of flipping the fraction. So the negative has done its job, it's out of here. You still just have the 4/3 cubed. And now you get to simplify that. That becomes 4 cubed over 3 cubed. If you have to remind yourself of that rule, imagine multiplying 4/3 times itself 3 times, because that's what that is by definition. Then on the top you have 4 cubed, and on the bottom you have 3 cubed. And that's going to equal 64 over 27. Now let's look at this other one. X to the 6th over x squared, the whole thing raised to the negative 3. There's actually more than one way to do this problem to start it. Some of you, based on what you saw here on this previous numerical example, might go, hey, I know exactly what to do. This negative exponent, it just flips the places of these. It does its job and creates, I'm going to bring this over here, it puts the x squared on top, the x to the 6th on the bottom, still raises the whole thing to the third power. So you have the negative doing its job of flipping, switching places, then everything else remains the same, and then you work on it from there. Which means you could apply the powers rule. This becomes x squared to the third, or x to the 6th, 2 times 3. On the bottom, x to the 6th to the third, which is x to the 6th times 3. Pardon me, or x to the 18th, and then you could use, by definition, there's 6 on the top, 18 on the bottom. 6 are going to cancel, leaving 12 on the bottom. Or you could use your rule and say top minus the bottom is x to the negative 12, and that negative puts it in the other spot, 1 over x to the 12. So there's a lot of rules here I could apply. Or did anybody think of starting it this way? Say, hey, I can deal with what's inside parentheses first. In other words, x to the 6th over x squared. Let's ignore that negative 3 for a minute, because that really cancels just down to plain old x to the 4th. The negative does its job and puts x to the 4th in the bottom. Then you raise that to the 3rd power, and you get x to the 4 times 3, or just x to the 12th. Lots of ways to think about this problem. Again, I said this earlier, one of the best ways to get comfortable with exponents is to do a lot of practice. And notice that right here, x to the negative 12 might have felt like it was an okay place to stop, but we don't want to stop until we get all positive exponents. So 1 over x to the 12th, 1 over x to the 12th is where you stop here, not x to the negative 12. So your final answer, one more time, should be all positive exponents. Okay?